One, we are given that if sine 20 degrees is equals to a, find the following in terms of a. I already explained in the previous ones that if we're having a situation like this, we have to draw a diagram, and this is more like a over 1. So we can draw our acute triangle like that. So we're given 20 there, so this is 20 degrees, and that will be our 90. So obviously this will make this 70 degrees like that, right? So that's a 70 degrees. And we're given that sine 20 is equals to a over 1. And we know that our sine of theta is equals to opposite. So this will be our opposite, and this will be our hypotenuse. So 1 is our hypotenuse, and a is our opposite. So opposite to 20, we have a, and our hypotenuse will be 1. So what's left is to find the value of the adjacent. So again, we can say our x squared plus our y squared is equals to our r squared. So this x squared plus a squared will be equals to 1. So our x squared will be equivalent to 1 minus a squared, which should be our x, will be equivalent to the root of 1 minus a squared. So here it will be the root of 1 minus a squared, like that. Like that, right? So now let's solve the following now. So sine 160, we can see that this sine 160 is way over. So it means that we need to reduce this. So this is equivalent to sine of 180 minus 20, and this falls in the second quadrant, so it will be positive sine of 20. So sine of 20 already, they gave us that is equals to a. So this is a, like that. So now we move to the next. They said cos of 70. So cos of 70, we look here. Fortunately, we have this 70. So 70 here, it will be adjacent over hypotenuse. So that's a over 1, which is simply a, like that. And we move to tan of 200, which again we can reduce by saying tan of 180 plus 20, which is tan of 20. And this is in the what? This is in the third quadrant. So cos is, tan is positive, like that. So lastly, when we are here, what is tan? Tan is adjacent. It's opposite of adjacent. So this will be just a over the root of 1 minus a squared. So now they said sine of 40, and you don't have 40 anywhere there on that triangle. So we can use the double angle of tan, of sine, I mean, sorry. So what is the double angle of sine? What does it say? So the double angle of sine says this is sine of 20 plus 20. So this will be equivalent, to 2 sine 20 cos 20. So this will be 2, and sine of 20 already we know that this is a, and cos of 20, it will be adjacent over hypotenuse. So that's root of 1 minus a squared all over 1. So this will be 2a, the root of 1 minus a squared, like that. So this will be our answer. So we need to see the relationship between the angle that you are given and the angles that you are having there. So once you can notice the relationship, it means that you can work with that, right? So I'll just rubber off some of the stuff, and you can continue with number E. We don't have F. So the F1 was saying 1 minus 2 sine squared 35. So let's just rubber off some of the stuff, and then we can work on F to H. So on number E, we are having 4 sine 10 cos 10. So how can we deal with this one? We can see that this is having sine cos, right? So it must be a sine double angle, but now we are having 4. So how do we deal with this one now? And 10 plus 10 gives us 20, so this should be a double angle of sine. So now we can factor out the 2. So if we factor out 2, it will remain as 2 sine 10 cos of 10. So that will make this the same as 2. It will be 2 sine 2 multiplied by 10. So this is equivalent to 2 sine of 20. And sine of 20 already, we saw that sine of 20 is A. So that will be, so our answer will be 2A, like that. So now let's move to this one, number F. So number F is saying 1 minus 2 sine squared 35. So how do we deal with this one now? We can clearly see that this is a double angle of cos, right? So it is saying 35. So this is equivalent to cos of 2 multiplied by 35. So this is cos of 70, like that. So what is cos of 70? When you add cos, it is adjacent over hypotenuse, so that's just A, like that.